Hello all, my name is Krishnak and welcome to my YouTube channel. In yesterday's videos, guys, I had actually created a tutorial saying creating pipelines using Sklearn, and I had actually shown you how to actually create a pipelines with the help of Sklearn by using this particular library, that is sklearn.pipeline, import pipeline itself, right? Now, many of you actually had a question that if you are using this particular pipeline, how can we do hyperparameter tuning? How can we do hyperparameter tuning with the help of grid search CV or randomized search CV? So in this particular example, I'll show you with the help of pipeline how you can go ahead and actually do hyperparameter tuning. And it is pretty much amazing. It is easy. So make sure that you watch this particular video to understand the whole thing. So I'm just going to execute this line of code till load iris.data, and I'll also I've also executed this xtrain, dividing the data set into xtrain and xtest. Now if you remember, this is my pipeline code. I was actually creating standard scalar pc, and then we tested for logistic. Then we did again for second pipeline standard scalar pc, and we actually created for decision tree classifiers. And again, guys, if you have not seen that particular video, the link is given in the description. Please have a look onto that, then you will be able to understand. Now what going to do is that I'll try to compare different algorithms, machine learning algorithms, considering hyperparameter tuning in mind. Okay, so how do we do that? So I'm going to go down. Okay, first of all, I'm going to import the grid search cv. So I'm just going to import the grid search cv over here. So from sklearn.model selection, I'm going to import this. Now when I'm making the pipeline, okay, just remember, when I'm making the pipeline over here, the pipeline that I have actually selected is random forest classifier. Okay, but still we need to test with different kind of parameters. So these are the parameters that I will be selecting. And always remember, guys, suppose I've created my pipeline with this particular name, that is classifier. Okay, then over here, when you are defining the parameters, first of all, you just consider this as an example. Right now I've just taken random forest classifier. Now inside this, when I am creating the key value pairs for the parameters that it has to be tested in grid search cv. So first what I'm going to do is that I'm going to, considering this particular keyword, we have to use this keyword only. So in the first case, I'm saying that, okay, change the classifier to logistic regression first of all. Okay, then in logistic regression, you have one parameter which is basically used for hyperparameter tuning, which is called as penalty. Now this penalty, when you're using as a key value pairs, if you have made a pipeline, you have to use this particular keyword classifier, and then you have to write double underscore penalty. Okay, so penalty is my hyperparameter inside logistic regression. If I want to write it out, I have to basically use this keyword classifier underscore underscore penalty. And what are the possible options of penalty? One is the L2 parameter and L1 parameter. Similarly, there is another parameter which is called as C inside logistic regression. So if you want to also write this, what you have to do, you have to use this keyword classifier underscore underscore C. Okay, and then I'm taking various C values over here, like 0, 4, 10. Okay, now this is my first hyperparameter tuning parameters that I have to play when my classifier is logistic regression. Now in my second case, what I'm going to do is that I'm going to again consider logistic regression. Here I've taken the penalty value as L2, and underscore underscore C value is same like this, but I have taken one more parameter which is called as classifier underscore solver. Now here I've actually selected Newton underscore CG, Saga, SAG, limb area. Okay, so and make sure that why I've not written L1, because this solvers will not allow an L1 penalty. It is just applicable to an L2 penalty if you know about logistic regression. Now in my third, I'm basically using a logistic classifier. Okay, again, these all are key value pairs. I told you, right? This is another key value pair. So here my classifier is random forest classifier. I'm initializing it here. Now with respect to the parameters, I'm using n underscore estimators. Now if I want to use it, I basically need to write this particular keyword classifier underscore underscore n underscore estimators, because the classifier is basically my random forest classifier over here. Now the possible n underscore estimator values I've taken 10, 100, and 1000. This basically means the various kind of decision tree, like how many decision trees I'm going to take. Then my second parameter is basically max the underscore depth. Here I'm taking 5, 10, 15, 25, 30, none. So I've just taken some random values. Over here again, I have minimum underscore sample underscore live. So here I have the values like 1, 2, 5, 10, 15, 100. You can give any number of values. max underscore leaf underscore nodes in my next parameter inside random forest classifier. I've taken 2, 5, 10. Now this is how you have actually created a key value pairs. And how did you create it? Remember, whatever classifier you have, right? All you have to do underscore underscore along with the parameter that is present inside this machine learning algorithm. Pretty much simple. Now this is my grid underscore param. Now what I have to do is that now I have to initialize the grid source CV. The first thing is basically my pipeline, which is over here. Now, when I provide this grid parameter, which is my parameter over here, first of all, it will try with all this particular parameter, considering the classifier logistic regression. Then it will try with this. Inside this, it will try with different parameters of C, penalty, similarly, or this solver also. Okay, so it is going to do a permutation and combination considering various parameters. Here I have also taken the cross validation is equal to 5. My verbose is 0 and underscore jobs is equal to -1. After this, once I initialize grid search CV, all I have to do dot fit on X train and Y train. Now, when I execute this, guys, it is going to take some time to execute, okay, because it is doing so many permutation and combination. If you have a slow system, it will definitely take more time. If you have, suppose, if in a RAM you have 16 GB along with that, your processing power, your processor is basically i7, so it'll happen within 5 minutes, okay. So once you execute this, it will take some time, it will get executed. Now, if I want to test which is the best estimator that has got selected, so I'll write best underscore model. And this is my estimator that has got selected, where my logistic regression is selected, the C value is selected like this, the class weight is here, scaling is here, the warning penalty parameter is selected as this. And if I go and see the score by giving the X test and Y test, here is what I'm getting, 95%. Now understand what has happened. If I go above, my logistic regression had given me 86% without applying any hyperparameter tuning. But now, when I applied hyperparameter tuning with the help of grid search CV and pipelines, I'm able to get around 95% of accuracy. Isn't it amazing? You know? So make sure that this is how you can actually do a hyperparameter tuning with the help of grid search CV. All you have to do is that create this kind of key value pairs, initialize a particular algorithm, and then leave it to the grid search CV. It will do all the permutation and combination. It will find you the best result, and definitely you'll be able to get a very good score. So yes, this was all about this particular video. I hope you like this particular video. And one more thing, guys, over here, I think logistic regression had given us better results, but here I had actually done some PCA components. I reduced the dimensions, but just try to execute without reducing the dimensions on the top of code. Again, the code will be given in the description itself. You can download it from my GitHub, and you can definitely test it out, right? So yes, this was all about this particular video. I hope you like it. Please do subscribe to the channel if you're not already subscribed. I'll see you all in the next video. Have a great day ahead. Thank you, one and all.